Hi, Professor. Today I'm going to present a week 4 assignment, which is the questions here. If you receive a random sample size of 345 that is drawn from a population with a mean of 150 and the standard deviations of 180, what is the standard deviations of the sample mean? Finally, what does the standard deviation mean in these questions? So first of all, given a random sample size of n equal to 345, a population's mean is equal to 150 and a population standard deviation is 180. So the deviation of the sample means, also known as the standard error, based after I calculated, is estimated around 9.7. So the standard deviation of the sample means approximately 9.7 indicate that expected variations in sample means if multiple samples of 345 were taken from the population. And this measure reflects the precisions of the sample means as estimated of the population mean, and similar or smaller standard deviations will imply the sample mean is likely to be close to the actual population mean. So when we assume for the confidence intervals at 95%, the following could be considered. For example, a random sampling. The data should be obtained through a process of random sampling from the population, ensure that each individual has an equal chance of being selected. Secondly, will be normality, which the population the distribution is not normal. The sample size should be sufficiently large for the central limit theory to apply, ensuring that the distribution of the sample means approximately normal. And lastly, independence. The observation should be independent of each other, meaning that the section of one individual does not influence the section of another. And these assumptions are crucial for accurately estimating the confidence interval level and ensure the validity of statistic inference. So the following are the hypothesis testing for standard deviations. And after given that we have a sample size of n equal to 32, we can use the chi-square test for variance. And for example, we will find out the test statistic will be our estimated 19.85. So the crucial values for a one-tail test at 0.05, with a degree of freedom, we can look up the crucial values in chi-square distribution table. And in this case, 19.85 is less than 43.77 after the calculations of crucial values. The conclusion is, since the calculation chi-square statistic is less than the crucial value, we fail to reject the known hypothesis, and this indicate that there is not sufficient evidence to support the claim that the population standard deviation is less than 13 hours. Therefore, the sample data does not provide strong enough evidence to conclude that the standard deviation is significantly below 13 hours. This is all my reference. Thank you so much for listening.